So we're going to be looking at the graphs of the quadratic function and learning some more characteristics about it. You're taking this, you already know some things, and we're going to look at some review things here that go back to probably lesson 84, lesson 83, earlier in this unit that are going to deal with quadratic functions. All right, so let's look at a few of those important concepts that we've seen so far. Important concept number one, the standard form of a quadratic equation. Who can tell me the standard form of a quadratic equation? Some of we already talked about this a little bit, right? Alec, what is the standard form of a quadratic equation? Y equals, it's got to be an equation, right? Y equals ax squared plus bx plus c. All right? This is called the quadratic term. This is called the linear term, and this is called the constant, right? So we've got a quadratic term, we've got a linear term, and then we have our constant, okay? Each one of those things has a little part to play. Which piece dominates the equation? The quadratic term, right? Obviously, if we're squaring a number, it's going to have a larger effect than just plugging the number in and multiplying it by whatever b is. Squaring it, that's why that dominates the shape of the graph. Okay, so that's the standard form of a quadratic function. Okay, quadratic equation. The graph of a quadratic function is a parabola. That was one of our bell work questions. It's important to remember that. The graph of a quadratic function is a parabola. If a is positive in the standard form, the parabola opens upward, right? We always know that, right? So it's going to open upward and have a U shape that would hold water, right? Okay. If a is negative, you don't necessarily have to write these down because these are review points. If a is negative, the parabola opens downward, right? So it's going to be upside down and look something like this, okay? It'll kind of shed water. It won't hold water, right? So it opens downward, all right? Today we're going to get a few more parts, pieces. The anatomy of a parabola is what I like to call this. How can we label the different pieces? And it's not a super complicated shape, is it? Okay, but if I drew a parabola here, I don't want to do that. If I drew a parabola, like, here's my parabola. That's actually a pretty good sketch for me. I'm can't draw stick figures. Somebody tell me something that you notice about it. Positive. A is positive, right? Good. Make another observation. If we're talking about the pieces or the parts of this thing, you see any important pieces or important parts? It really only has one really important part, right? What is that? Do what? Quadratic. Well, this pieces of this actual physical graph. The shape, right? But what's significant about the shape? It's U. How wide it opens? That's pretty, because they can be different, right? They can have different values. It could be kind of wide like this, kind of wide like me. Yeah. All right. So it could have a different U shape. But again, what's the important piece there? Yeah, I mean, you're giving a name to it. This little part right here is really the only significant piece of the anatomy of the parabola. Just about everything that's going. Now, if I put it into a coordinate system, right? If I did this, then all of a sudden the parabola could have some more important pieces that we could talk about, right? What else could we talk about now? Yes, Hannah? Where is it located? Right now it's not just out there in space. We've put it in a coordinate plane so we could talk about its location point. We could talk about these things right here, right? What are those called? X-intercepts. We could talk about that thing right there, which is the y-intercept. So we're giving it some more pieces when we put it into the coordinate plane. But the anatomy of a parabola, the most important piece of a parabola is the vertex, okay? It's the highest or lowest point on the parabola. It's also the turning point. It's the place where it changes direction. How many times does a parabola change directions? Once, right? It's coming down and then it turns and goes up, or it's going up and then it turns and goes down. How many times does a line change directions?
0.
0 times. So a first degree function, a line, changes directions 0 times. A second degree function, a parabola, changes directions 1 time. How many times do you think a third degree function might change directions? Twice. And maybe a fourth degree might change directions 3 times. So we could talk about those types of things as you learn more and higher degree functions. So, but the vertex is the turning point of the parabola. Okay? All right? Now, the maximum value of a function, the maximum value of the function, the parabola, is always going to be the y value of the vertex when a is what? Think about it. If it has a max, it's going to do that, right? So it's going to have a maximum point, a peak, if a is negative. Okay? So if it has a maximum value, a has to be negative, and the maximum value is the y value of the vertex. Just the y value. All right? Now, if a parabola could have a max, then it might have a minimum value. When would it have a minimum value? When a is positive, right? So the minimum value of the function, the minimum value of the function is the y value of the vertex when a is positive, right? So if it has a min, that means it's opening up. It's got a low point. It's cupped like that. There's the minimum value right there at the vertex, okay? So minimum values occur when the parabola has a positive a value. The minimum is the y value of the vertex. That's very important. The minimum value of the function is always a y value. It's not an x value. Okay, so let's look at an example. Y'all ready? When a is positive. Okay? All right. Whoa. Now this says to identify the vertex and the maximum or minimum value of the parabola. Is this going to have a max or a min? Minimum. It's going to have a min, right? Because a is clearly positive. It opens up. It's got a low point. It's a minimum. What is the vertex?
-8.
Now the vertex is a point, right? So we're looking for this point right here.
-4.
A point has an x value and a y value. So the vertex is 0, -4. We're getting there. 0, -4. Okay? All right. Yeah, you got to look at the scale of your graph. What's the minimum? So the minimum, this parabola has a minimum of -4 at x equals 0. Now that's the most technical way to write this. It's perfectly okay to say the minimum is -4. It's not okay to say the minimum is 0 -4 because the minimum is just the y value of the vertex. All right? Just got to keep that straight. What about this one? This one has a peak instead of a valley, right? So it's got a max. What's the max? You think the max is 5? All right, let's start with the vertex. What's the vertex?
1, 5.
It looks like we're going by 2s here, right?
Oh, yeah, you're right.
All right, I'm going to put a question mark by that because we're guesstimating that, right? We don't have a point there telling us it's 2,5. How could we confirm that it was actually 2,5? Plug the x value into the equation, and we would get, what? -2 squared plus 4 times 2 plus 1. Does that equal 5?
Well, let's see.
-4 plus 8. No, -4 plus 8 is 4. 4 plus 1 is 5. So, yeah, we're good. We can be definitive about that. All right? Vertex is 2, 5. What's the max? Maximum value is 5, and it occurs at x equals 2. That's going to be important later. You'll see our last example of the day, most challenging thing we're going to do today is going to involve this type of language, so I just want you to see that. All right? More anatomy. The zeros. Have y'all heard that term before? Is this the first time you've heard that term? The zeros of a function? Okay. The zeros of the function are the x-intercepts. In this case, we're talking about parabolas, but any function, if we're talking about the zeros, we're talking about the x-intercepts. Right? A second-degree function can have two x-intercepts because how many times can it change directions? It can change, the second degree changes once, so it can touch the x-axis and then turn and come back up and touch it again, or vice versa. But it can't touch it more than twice. A second-degree equation has two solutions, two roots, two zeros, two x-intercepts. Okay? All those words are synonymous. Okay, y'all with me? So the parabola has x-intercepts. We saw that graphically just a moment ago. What would the x-intercepts, the zeros, the roots of this equation be? What's your name, hon? Ashlyn. Ashlyn? Tell me one of the x-intercepts. Can you see that well enough? It's on this side, so it'd be what? -1. All right? Give me another one, Hannah. Positive 3. So -1 and positive 3 are the two zeros. Right? Y'all with me on that? Okay. So can you imagine what the parabola might look like if it only had one zero? What would it have to look like?
A line?
No.
Maybe on
It's still a parabola.
It just stops it.
The vertex would have to be sitting on the x-axis, right? Like that, or it could be turned around. So what's the single? So this one only has one x-intercept. What's the x-intercept here? -2, right? So the x-intercept, the zero, is -2. Does everybody see that? Sitting right on the axis. Where does it cross the axis? This one crosses at -1 and positive 3. So that's the two zeros. This one crosses only one point, and that is at -2. So that's the x-intercepts, the zeros, the roots of the parabola. Okay? Y'all with me? Now, can you imagine what the parabola might look like if it had no zeros?
Mm-hmm. Well, yes. You just scoot it up a little.
You could just slide this parabola up a little bit, maybe put it somewhere like right up here, right? It's never going to cross the x-axis. Or we could put it down here. Never going to cross the x-axis. So a parabola can have two x-intercepts, zeros, one zero, or no zeros.
Would the equation just be like squared? Like, what would the equation be?
Well, I can give you an example real quickly of one. We're not going to go too far down this rabbit hole, but y equals x squared plus 1.
Yeah, I was thinking it wouldn't have an x.
See, because the x-intercept is where y equals 0, right? Where y equals 0. Can this y ever equal 0?
No, because it's plus 1.
Because it's something squared, which is positive, plus 1, which is positive. X squared plus 1 can never equal 0 in the real numbers.
That's cool.
Because in order for x squared plus 1 to equal 0, x squared would have to equal -1, and that ain't going to happen. You can't square a real number and get -1. Okay? All right, so let's move on. More anatomy. Every parabola also has an axis of symmetry. The axis of symmetry is a line that divides the parabola into mirror image halves. I have a hard time saying mirror. Mirror image halves. Both my children, my boys, had trouble saying their alls. I guess they got that from me. Mirror image halves. Just a weird word. It's a vertical line that passes through the vertex, right? Now, that makes sense. If it's going to have a symmetry line, or if we've got a parabola and we've got a vertex there, the line of symmetry is going to have to be a vertical line that kind of splits it right in half into two mirror halves of each other. So the parabola has symmetry across this line. Now there's some important stuff here. What is the equation of a vertical line?
X equals something.
X equals something, right? We already know this, so it's x equals a number, is going to be the axis of symmetry. Okay? It's going to pass through the vertex, so the axis of symmetry is the x value of the vertex. Makes sense, right? It has to be x equals a number. It has to pass through the vertex, so it's x equals whatever the x value of the vertex is. All right? Here's an important note. Very important note. Huge. Because of the symmetry of the parabola, the axis of symmetry will always occur at the midpoint of the zeros. All right, now we've got two new definitions in the same note here, right? Actually, we're talking about three things. The symmetry of the parabola, the axis of symmetry, always at the midpoint of the zeros. What are the zeros again? The x-intercepts, right? So if a parabola has two x-intercepts, then the axis of symmetry has to pass right between them if it's symmetrical, right? Does that make sense with mirror images? So if we know the zeros, we can find the axis of symmetry by taking the midpoint of two things. Now, how do you do a midpoint?
Wouldn't the midpoint just be the vertex?
The midpoint is going to pass through the vertex. That's right. It's the x value of the vertex. How do you find the midpoint of two things?
You go to the middle.
All right, what's the midpoint? Let's do an easy one. Perfect. What's the midpoint of 2 and 4? 2 and 4 has a midpoint of 3, right? Because 3 is right in the middle of 2 and 4. Say again, Aiden, how you find that?
Add both of them together and then divide by 2.
You can add and divide by 2. The midpoint is actually the average of the two zeros. If we add two things and divide by 2, we're taking the average of those two things. Okay? Now let's take these three definitions. Remember, mathematics is learning facts. Right? Reagan, we're going to learn facts and we're going to apply the facts. Okay? So I've got these three facts. I'm going to apply these three facts. Okay? So, here's a question. Find the axis of symmetry. Look at this for a second. Don't speak it right out. Let's go back to the definition of the axis of symmetry. What's the definition of the axis of symmetry? It's a vertical line that passes through the vertex. It's always x equals some number. The Starker, what does x have to equal here, you think? What's the only x value I'm given in this whole problem?
Negative 4.5.
Yeah. If it's the vertical line that passes through the vertex point, right? This is the line that I'm talking about right there. Vertical line, the equation of that vertical line is x equals some number because it's vertical. In this case, it has to be x equals negative 4.5. So that's the axis of symmetry. That's the midpoint, the dividing half of the parabola into two symmetrical halves. Okay? Let's complicate it a little bit. What about this one? Don't just speak it out. What are we given in this one? What's the given information?
The two x-intercepts.
We're given the two x-intercepts, and we're told to find what?
The
axis of symmetry. What do we know about the relationship of the axis of symmetry to the two zeros? It's the midpoint. It's the average of the two zeros, right? So we need to find what's right in between negative 3 and positive 5. You had your hand up. What's it going to be?
Wait, what do I mean? I was like, I didn't.
1.5.
Is it 1.5? It's the average, right? What's negative 3 plus 5 divided by 2?
1.
It's 1, yes. X equals 1 is the axis of symmetry. Now, isn't that what we would have guessed? Isn't that what we would have guessed just by looking at the graph? Doesn't that look like x equals 1?
At first I was thinking you would find like absolute value of both of them, then add, but then just, no.
No. The average of two things is the two things added and divided by 2. Midpoint is one of the only formulas in math that doesn't involve subtraction. You think about it? Right? What are the formulas you know so far? Slope, right? Difference in y's over the difference in x's. Distance formula, y2 minus y1 squared plus x2 minus x1 squared, square root of those things. Lots of minuses. Just about all formulas in mathematics have subtraction, except for the average formula is pretty, you add everything together and divide by whatever's there. Okay? So the axis of symmetry is the midpoint of this. Now there's also a formula for the axis of symmetry. Okay, so you need to write the text down here. This text right here. The axis of symmetry for the graph of a quadratic equation in standard form. It's very important that it be in standard form. We can't use this formula if it's not in standard form. It's x equals negative b over 2 times a. This is a formula. Okay? Now, I'm going to show you in just a moment. I'm going to show you where this comes from because I want you to see it, how it applies to everything else. But I'm going to have to show you something that you haven't quite learned yet. You're going to learn it soon, but you haven't learned this yet. Just write that text there, and that formula is extremely important. You're going to need to memorize that formula for your test on Friday. It's not a very difficult one to memorize, though, right? X equals negative b over 2a. What is that the formula for?
Y.
The axis of symmetry. Now, it just so happens, though, that negative b over 2a is also going to be the x value of the vertex, right? Because the axis of symmetry passes through the vertex, x equals negative b over 2a is this. All right, now, put your pencils down. You don't need to write this down. You don't need to remember this, but don't check out because I think some of you might find this pretty cool. Does anybody know the quadratic formula? You heard of it? Maybe. All right, the quadratic formula is the formula that we can use to solve any quadratic equation. All right, the quadratic formula tells us that it has two solutions, right? It's quadratic. The two solutions are x equals negative b plus the square root of b squared minus 4ac, all divided by 2a. And the other solution is x equals negative b minus the square root of b squared minus 4ac, all divided by 2a. Where that a, b, and c just comes from the standard form of the quadratic equation. That's the two x-intercepts. Are y'all listening? That's the two x-intercepts. Now, you haven't learned this yet, but it's coming soon. What did we just say the relationship of the axis of symmetry was to the x-intercepts or zeros? It's the midpoint. How do you find the midpoint of two things? You add them together and divide by 2. Now, look, something nice is going to happen when we add these two things together. Right? You see that plus right there and that minus right there? What's going to happen to these two things when we add them together? They're going to cancel each other out. That real complicated, ugly part goes away. So if we add these two things together, if we take x1 and x2 and we add them together, we're going to get negative 2b over 2a. Right? Now, what's going to happen if I divide it by 2? Take the average. It's the same as multiplying it by 1/2, isn't it? If you average those two things together, this 2 cancels with that negative 2, and what are we left with? Negative b over 2a. All right, so algebraically, we use the quadratic formula to show that the midpoint, the symmetry point between the two zeros is negative b over 2a. All right? You're not going to need to know that just yet. But let's look at this. Let's put this to use. We're almost done. Not 5 more minutes. Y'all stay with me. Find the axis of symmetry for the graph of each quadratic function. Letter A. Find the axis of symmetry. Write this down. It's going to be x equals negative b over twice a. What's negative b? Negative 6 over 2 times 1. That's x equals negative 3. Now, I'm not told to here, but couldn't we use that value to find the vertex? Because the axis of symmetry always passes through the vertex, right? So the vertex is going to occur when x equals -3. And how can I find the y value that goes with the -3?
Plug in the x.
Just plug it in and find that's going to be -3 squared is 9 minus 18. That's -9 plus 5, which is -4. The vertex would be -4. All right? Pretty cool, right? What about letter B? Try it on your own. Write the formula every time you use it today and tonight in homework, and you'll have it memorized for your test on Friday. X equals -b over 2a is our axis of symmetry. So x equals -3 over -4 is positive 3/4, right? So there's my axis of symmetry. Keep in mind the axis of symmetry is a vertical line, so it's always an equation. It's not just 3/4, it's x equals 3/4. It's a vertical line through 3/4. Now let's put this into practice, all right? A golf ball is hit from an elevated platform 10 feet above the ground. It starts with a vertical speed of 160 feet per second. Ignoring friction, the equation y equals -16t squared plus 160t plus 10 gives the height y as a function of time, t. So instead of x and y, what do we have here? T and y, right? So t is my x in this. So it says, find the highest point. What's that asking us to find? It's asking us to find the max. What is the max? It's the y value of the vertex. So to find the max, I need to find the vertex. Okay? And then how long it takes to reach it. Now we just did this in that previous example. I showed you how to find the vertex. First we have to find the what? The x value of the vertex, which is at the axis of symmetry. So I need to use t equals -b over 2a. Just using t because this has t and y instead of x and y. Time is the independent variable, right? So t equals, make your substitutions, -160 over 2 times -16. The -16 and the -160 is positive 10, right? Positive 10 divided by 2, t equals 5 seconds. All right? That's actually, we found this question first. How long does it take to reach the height? The axis of symmetry takes place, the maximum value takes place at t equals 5 seconds. Now how am I going to find the actual height? Plug it in, plug it in. That's right, -16 times 5 squared. Y'all don't remember that commercial, do you? Wow. Plus 160 times 5 seconds, plus 10. And that will give us -16 times 25, it's -400. 160 times 5, 800. Plus 10, it's going to be 410, isn't it? So let's put our answer into a statement. Okay? The max is 410 what?
Feet per second.
Feet at 5 seconds. All right? Good with that? All right, here's your homework. You guys are great.